This is Module 7, Part 3 of the Foundations of Programming with Python video series. In this part, I want to talk about structured error handling. So far, we have encountered multiple occasions in which Python has crashed on us and stopped working in our program. Some of the examples can be if the user has entered a value that was outside of our good specification, or remember in our math program we were encountering a zero division error if we were entering as the second number 0. So we had the zero division error, or same in the math program when we're doing an int conversion. So if you're actually trying to convert 2.5, the string 2.5 out of the input into an int, we were getting a value error because we can't convert 2.5 to an integer. Another error that we were seeing, most likely we're seeing as actually file not found error if you're trying to do a read operation on a file, on a text file that doesn't exist so far. So all this kind of, let's see, and the thing is, Python kind of catches all those errors. It is catching them individually. It can give us a feedback on what type of error we're seeing. Now this means that the error that is happening, the exception that is happening, Python is handling it in an orderly manner. Our program does not, but Python, the runtime itself, does. So there must be some form of an exception handling or error handling mechanic in Python, and this is the structured error handling, and it would be neat to actually use that to make our program behave and not crash, so that our program is actually handling those error states internally and keeps running. All programming languages have this capability of handling this in one form or another. In most languages you will see a construct that is very similar to Python's construct. The syntax might be a little bit different, how you invoke it might be a little bit different, but the principal idea is very similar. In Python we are using a try except block. Within the try block, we are encapsulating the code or the statements that we want to secure against errors. So if there is an error happening in this try block, Python runtime is going to be looking in the except block on how to react to those errors. So let's see this in action. So it is asking us within the try except block to enter an integer. So if we enter an integer, it keeps working. We are converting it to an integer and we are multiplying it by 2 and printing out the result. Now if I give it a 2.5, which is not an integer, instead of crashing what we did here, we're actually getting a custom message, and this custom message is out of the except block. So what happened is we are creating an error in the try block. The runtime looks in the except block on how to handle this. Same if I'm actually entering text, which also is not integer, it is giving us the custom message. So now if I'm exiting out of this while block, I'm actually getting into the second while block in this example that is basically doing exactly the same, but without the try except. So again, if I'm entering 10, it works fine. The moment I'm entering 2.5, it crashes on us with this value error message. So using the try except block for starting to use the structured error handling makes our program way more robust, and we actually can ask the program to behave in a certain condition if we're encountering errors. Errors or exceptions in Python are a class of their own. So what I'm doing here is I've expanded the except statement a little bit, exception as E. So I'm expecting an exception class and I'm setting it as E, as into the variable E, so that I actually can print out more information about that exception object. So let's generate a few. It asks me to enter an integer, so if I'm putting 10 in there, it works. If I'm putting 2.5 in there, I'm getting actually a lot of more information about this exception object. So the info in the exception object, first of all, if I'm printing E, so this print statement gives me the invalid literal for int of base 10. If I'm doing the type of E, I'm actually getting value arrow. So the class now all of a sudden is value arrow, although I actually invoked it as an exception object or class. So we get to that in a moment. If I'm looking at the arguments in my exception, I'm actually getting this tuple. Remember the trailing comma if the tuple has only one value with this text in it. And if I'm going for the dunder dog, so this dunder is actually a double underscore method within an object or a class. There are a few of those around. For now, go with it. We get to those in a little bit. I think it's in module 8 or 9 that we're getting to those. So if you're looking for the dog, we are getting the inappropriate argument value for correct type. If we are using the dunder string, we get the invalid literal for int with base 2.5. But the most interesting part right now is actually this type printout, because we are actually getting something different than the general exception. We are getting a very specific class of error with very specific attributes to it and methods to it, which kind of hints that we might be able to catch specific exceptions and handle specific exceptions individually. And this can indeed be done. So here I'm actually using, if my exception is a value arrow, then I'm using that as E in these statement blocks. If my exception is a zero division arrow, I'm doing this. If it's a file not found arrow, I'm doing this. And for all other exception classes that are not one of those three, I'm doing this block down here. So in order to actually be able to get the file not found error or zero division error, I changed the code a little bit, or expanded the code a little bit. So first we're doing an int conversion here. Then we are doing a division by the int that we entered. And then I'm simply doing a read access on a text file. And of course I don't have this text file to actually generate this file not found error. So let's fire this up. I actually need to exit out of the old one. Fire this one up. and it's asking me to enter a non-zero integer. So if I'm entering a non-zero integer, I'm getting the proper result, and I'm getting a file not found error. So this works, and I'm getting this file not found error down here. It's jumping to this one and giving me those error messages. Now if I put something in that is not convertible to integer, I am getting the custom error message that this is not an integer, and I'm getting the error information, but I'm not going down to the file not found error. So this means this try block is causing an error on this line, and with that the rest of the execution of this block is not done. So I'm jumping out of this block into handling exceptions. So keep this in mind, because this means all this code down here after your error occurred will not get executed. So all the handling of information that you're doing there is not getting executed, which also means if you need to roll back some information that happened before your exception occurred, you actually need to do that in the except block in here. So let's see if we can create a zero division arrow. It's the same here. So it's a zero division arrow, and it is handling it out here as we would have expected. So the int conversion worked, and then we're getting the zero division error. It's jumping out of here. And as you can see, we are using print statements here to actually give the user individualized feedback on the error that occurred. So here it's entering and dividing by zero is not allowed. That is not an integer, it's a custom message. And if the file does not exist, we actually give it text file does not exist error here. Okay, so let's exit out of this. Now, what kind of standard exceptions or errors are included with Python? Let's have a look at the Python documentation. So first we have the base classes, and then we have the concrete exceptions that are in here. And here's our exception class. So what this means, or what this hints at, is that we have all built-in non-system exiting exceptions are derived from this class. All user-defined exceptions should also be derived from this class. This means this exception class is the parent to any exception within Python. So there's a hierarchy to it. And if you're actually scrolling to the end of this help document, then you see here your exception, and then all the errors are derived of it. So we have seen our zero division error, we have seen our file not found error, and we have seen our value error. Now, this deriving classes from another class, talking about parent and child, this is all already going into object-oriented programming principles, where you have a parent class, you're deriving a class of this, making a child class. What this means is you're taking the functionality and the attributes of the parent class and this is being inherited into the child class. In the child class, you either can override what the parent class has been doing, or you can expand on it. So what this means is, for example, in the exception class, you can customize the exception error message that is coming out of the class, or you can go into more detail when this exception class is valid, like the value arrow. So there is your, if you can't convert to an integer, it's a value arrow. If you have an OS arrow, so you've got an operating system arrow, and then which is child of exception, and child of OS arrow is file exists error or file not found error. So this actually means this exception class is part of OS arrow, which means it has something to do with interaction with the operating system. So if interaction with operating system is generating an error, then it actually can look into the details here. This is the child, parent-child relationship here, and typically you keep the parents, the further up a parent is, the more principal and abstract it is, and you make it more precise, with more precise behavior, with more refined behavior, with more functionality, the more you're going towards child, or the lowest level child. So every step you are adding to it. This is the hierarchy that is in here. And I want to look into, we have here zero division error. So let's jump to the zero division error here. OS exception, zero division error. I want to so here is a zero division error, and what I want to point you to is we are printing out the type, then we're printing out E, we're printing out E doc. So here is our type, here is E, and here is our E doc. And what I want to point you to is that our second argument to a division or modular operation was 0. This is exactly this text. And as you remember, if we're pulling with Control I the help or the doc string up, then it's coming up here, and then the doc actually is pulling the same doc string up. So what this is actually doing, the standard doc functionality, is pulling up as the doc string out of this class itself, and it's printing this out. This is what I wanted to show you here. Now, having spoken of that, we have quite a number of individual exceptions already built in Python. This kind of, and have seen in the Python documentation that custom built exceptions shall be derived from the exception class, kind of hints that we can customize our errors and our exception classes and build custom ones. And this is what we're going to be exploring in part 4 of this module. See you in part 4 in a bit for this.